Okay, 13 says if we compress or vertically shrink the parent quadratic function by a factor of 2, which of the following will be true? All right, well, let's just do a little work here. So we have f of x equals x squared, and then the shrunk version of that, which is a is 1 over 2 because it's a shrink. So 1/2 x squared. So if we draw ourselves a little sketch here, you know that the parent function, you should be good at sketching this parent function now. It starts at 0, 0, 1, 1, and then 2, 4. That's those key points. 2, 4. And then the 1/2 version takes all these outputs and shrinks them by a half. Half of 0 is still 0. This one's going to be down here. This one will be down here. 1 divided by 2 is negative half. 4 divided by 2 is 2. So this second one here will be g of x equals 1/2 x squared. Alright, so let's think about what's going on here. Zeros will not change. Well, it's still, both of these graphs are intersecting the x-axis at the point 0, 0. So the zeros will not change. True. The vertex will shift from 0, 0 to 0, negative 2. Well, no, this is just a shrink. So the vertex, you can see here, is not moving at all because h and k are still 0, 0, and 0, even after we do the vertical shrink. So this one is false. The point 2, 4 will transform to the point 2, 2. Well, 2, 4 is this one right here. Well, the input stays the same, but the output does divide by 2. That's what a vertical shrink is. So this 4 shrinks down to 2. So that point 2, 4 will transform to 2, 2. True. The point negative 2, 4, so we're talking about this one here, will transform to negative 1, 4. So it's saying, is that point going to go from here up to here? Well, no. You know, this point is going down to here. So that one will be false. Graph will reflect across the x-axis. That's definitely false. We would need a to be less than 0 for that to happen. And the axis of symmetry will not change. Well, that's true. The vertex isn't changing. So the axis of symmetry will also not change. So that one is true. Alright, evaluate whether these two transformations produce the same function. Horizontal shift to right 2. So here's the parent function. Horizontal shift of right of 2. So that's going to go over 2 units. And a vertical shift up. So here, this A one will, the shape's not going to change because A is not moving, it's just being slid over. So this one is A, and 14 is B, a vertical stretch by a factor of 2. Well, that's just a stretched Armstrong. So if we start with f of x equals x squared and just pull up on the arms, that point's going to stretch up to there, that point's going to stretch up to there, etc. And so this will be the B equation. Well, it's pretty clear here that A and B are not the same thing. A is not the same functions, so no. Alright, so here we're doing some complete graphing. Got to label axes, label vertex. Okay, we'll just do the complete graphing here. So I'm just going to try and be smart about how I'm going to set my graph up here. This, I can tell it's going to be a frowny parabola this way. And, you know, the vertex, I can already tell is going to be high up there. Because h is negative 2, k is 9. So the vertex will be negative 2, 9. So I'm going to go ahead and draw my x-axis low here. And then we'll put the y-axis kind of right in the center. Okay. So we've labeled our axes, and we're going to first find and label the vertex. Well, this is in vertex form, so that's easy for us to do. The vertex is going to be -2, 9. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there is the vertex. We know it's a frowny parabola, so well, it's going to go down from there. What we can maybe do next is find the y-intercept. Remember how to find y-intercepts? You just plug in x equals 0. So f of 0 is going to be -0 plus 2 squared plus 9. That's -4 plus 9 equals 5. So 0, 5 is going to be our y-intercept. So 0, 1, 2, 3, 4, 5. We know our line of symmetry is going to be through the vertex. And so I'm going to go ahead and draw this point here by just knowing that we're going to be symmetric here. So that gives me another point. And then the last thing I'm going to do is find the zeros. Well, the way I find the zeros is set f of x equal to 0. -x plus 2 squared plus 9 equals 0. I'll move that to that side to get x plus 2 squared equals 9. Then I'm going to go ahead and take the square root of both sides. X plus 2 equals plus or minus 3. And we have to take plus or minus when I take the square roots when solving equations. X is going to be -2 plus or minus 3. So x will be -2 minus 3, which equals -5. Or x will be -2 plus 3, which equals 1. So these are my two zeros here, so let's go ahead and find those. 1 will be right there, and -5 is 1, 2, 3, 4, 5. And then looks like this is going to give me what I need to sketch my parabola. If I wanted to, I could also evaluate, say, x is -1. So f of -1 would be -1 plus 2 squared plus 9 equals minus 1 squared plus 9 equals 8. So at -1 here, my point will be 8. And I can use symmetry to get that point. And so now I've got a nice set of 7 points to draw that parabola. Okay, for 16 here, note that this one is now in intercept form. So maybe the first thing to do then is to, and I see that A is 2, which is greater, so this is going to be a smiley parabola. So I'm going to maybe, no, I don't know exactly what, but I'm just trying to think about where to put the axis. I'm going to put it a little bit on the lower side because it smiles up. But who knows, I may end up missing it. Then draw the y-axis in here. Okay, first thing, it's in intercept form. I think it's the easiest thing is to find those intercepts. Well, one intercept's going to be at 1, 0, and the other one will be at 3, 0. That's where these factors equal 0. And so the first one here at 1, 0, the second one at 3, 0. So that gives us 2 of our points. Those are the x-intercepts. Maybe for now from here we can find the vertex. Well, remember the vertex is always halfway between the intercepts. So halfway between 1 and 3 is going to be 2. So we know that the x-coordinate of the vertex is 2. To get the y-coordinate, we have to just plug in 2. So f of 2 equals 2 times 2 minus 1, 2 minus 3. This is 2 times negative 1. I'm sorry. 2 times positive 1 times negative 1. And that will give us negative 2. So the other coordinate of the vertex is negative 2. So we know down here is our vertex. We know that this is our line of symmetry now, which is x equals 2, line of symmetry. And let's go ahead and find the x-intercept, the y-intercept. Again, we just plug in 0 to do that. 2 times 0 minus 1, 0 minus 3 equals 2 times negative 1 times negative 3 is 6. So 0, 6 will be our y-intercept. So 0 is here, 1, 2, 3, 4, 5, 6. And then we can go ahead and use symmetry to know that this point will also be there, which is 3, 6. So that gives us 5 of our points, and we can go ahead and sketch this slightly skinny parabola, which we knew was going to happen because a was 2, so it was a vertical stretch of the parent function parabola. Sorry, that should go through the vertex there. And there we have our sketched parabola.